Welcome back to school, everyone. I hope you had a wonderful Memorial Day weekend with your family. I'm excited because our city is starting to open up, so hopefully you enjoyed the beach, maybe even had a little food out at a restaurant since that opened up before the holiday weekend. We are now moving into the inequalities section of our chapter 8 for our math book. And we're going to start with an introduction to inequalities. First of all, let's talk about that word, inequalities. It sounds kind of like equality, right? Or if you can see in there the word equal in the title, but it's inequalities, meaning not equal. And so unlike equations where you had a variable equal to a specific value, meaning there was only one solution, you're going to find that in inequalities, there are numerous solutions and oftentimes an infinite number of solutions. And so the variable will represent a multiple of solutions. And we're going to learn more about that now. So in looking at these images I have state minimum wages. I have the weight capacity or maximum capacity for an elevator, which is 1,800 pounds. I have another picture here. I believe it's probably from an elevator, the bottom left. It says 9 persons max, 1,000 kilograms, or, I thought this was funny, 1 horse, or you could have 5,050 bananas, or 6,666 hen's eggs. So I'm thinking this is probably in the countryside somewhere. Maybe it's a lift. Maybe it's a truck. I'm not real sure. Anyhow, there's that one. And then there's this license with the expiration and the person's date of birth. It is a fake license. But what do these all have in common, I guess, is what I want you to take from this. What are your thoughts on how we would write a mathematical sentence to fit each of these scenarios? That is what you're learning today. Okay, so you have, I have more images. Hold on. These ones you'll really relate to. Do you remember when you were too short to go on the roller coaster you really wanted to ride? So the minimum height requirement for this motion only one is 42 inches. So not quite 4 feet. And then you have the extreme scream. You must be 52 inches tall. Okay. So in all of these, they represent an inequality, meaning they have many solutions. There is not just one value or one number that is true for these scenarios. Okay, so let's go back and look at them again. So if you look at the state minimum wage, you see the word minimum. That means there is a floor that it cannot go past that value. It cannot be less than that value. So for the state of California, and this picture is old, obviously, but since we're in the state of California's minimum wage at one point was $11. That means that anybody who was working in the state of California could not be paid less than $11 per hour. Less than. Could not be less than. So remember the inequality symbol? Less than, and we'll go over these in a little bit. That's less than. Okay. Then the next one was this elevator's maximum capacity. So now you're using the word maximum. And the maximum capacity is 1,800 pounds. That means you cannot go over 1,800 pounds. It doesn't mean it has to be equal to 1,800 pounds. So its maximum weight capacity is 1,800 pounds. So again, you have to use the less than sign. The same would be the case for this other elevator or carriage or whatever this picture represents. California driver's license, you could use different words. We've used so far maximum to represent solutions less than it. We've used minimum to represent solutions that would be greater than that. Excuse me, I got to make sure I have the greater sign. Now we have driver's license. You have to be at least 16 years old. Okay. Could you be 16? Yes. But could you be older than 16? That is also yes. That means there's more than one solution to this scenario. We would then use an inequality. So you would be greater than or equal to. And we'll talk about this in a minute. The same with these heights. There's a minimum to ride these roller coasters. But you cannot be exactly those heights. You could be, but you could also be taller or greater than. So you're going to be using that greater than or equal sign. So let's talk about what an inequality is. And it is a mathematical sentence that compares quantities. So that's the definition right here. The symbols, now you're used to less than and greater than. What you have maybe seen in ALEKS when you've worked on your knowledge path is now that we have variables, we have to have symbols that will represent not only less than or greater than, but also equal to. Because the variable, if you look at the previous situations, the maximum weight is 1,800 pounds for that elevator. That means the weight could be 1,800 pounds, but it also could be 1,700 pounds. It could be 100 pounds. It could be 529 pounds. There's going to be so many solutions. Now it could be 0. It's not going to be negative, but it could be 0. So any number in the number system from 0 pounds to 1,800 pounds. So we need to be able to write less than or equal to together without having to write two symbols. So what they've done is they created the symbol less than or equal to. And what this does is it combines the less than symbol with the equal symbol. And the same is true for the roller coaster. You have to be a minimum height of 42 inches. That means your height could be 42 inches, but it also means your height could be 72 inches or 48 inches or 49 1/4 inches. So there's so many solutions that your height could represent. So we have to be able to write a mathematical sentence where it includes all the heights greater than 42 inches, but also equal to 42. So that is greater than or equal to. So you're just taking the greater than symbol and you're adding to it an equal sign, but only one line of the equal sign. So it's not two lines, it's just the one line. So that's greater than or equal to. Okay. And let's go ahead and use the different examples above. Let me take the elevator. 1,800 pound maximum. Okay. This means that you could be 1,800 pounds. This is the weight, right? So I don't know the weight. The weight's going to vary depending on the time of day, who's riding the elevator, etc. So I'm going to use W because that's the unknown weight. All I know is that weight can be less than 1,800 pounds, but it can also be equal to 1,800 pounds. And so we use that combination of weight is going to be less than or equal to 1,800 pounds. The other example, let's do minimum. Minimum height of 42 inches. Okay, so my height, we don't know it, there's several people, 100 people, thousands of people that ride roller coasters at Magic Mountain or Disneyland or Knott's Berry Farm. But no one can ride this roller coaster if they're under 42 inches. They can be greater than 42 inches, but they could also be 42 inches. So that's greater than or equal to 42 inches. Okay. A non-example is, for instance, an equation. I was trying to think of one that makes sense, but for instance, x plus 15 equals 20. Well, that means that the value for x, when added to 15, must equal one solution, or one number 20. That means there's absolutely only one number that can be the value of x in this situation. If I solve using my one-step equations, x must be equal to 5. So this is a non-example because this is an equation where x is one solution or equal to one solution, whereas in an inequality, the variable is equal to multiple solutions and sometimes an infinite number of solutions. Okay, so let's move on to, I put this in here because I want to remind you about your less than and greater than. So a lot of you learned in elementary school that the crocodile eats the bigger number, which is true. Or you could say the small side of the inequality points to the smaller number, whatever that is. The score after 2 goals is blank the score after 3 goals. So we're using less than or greater than. So the score after 2 goals is less than the score after 3 goals. The cost to download 10 songs is blank the cost to download 2 songs. Well, that's going to be greater than. So I'm having the crocodile eat the 10 songs, not the 2 songs. The outside temperature in summer is blank the outside temperature in winter. It's hotter, which means it's higher in the thermostat, which means it's greater than the outside temperature in winter. Winter can even get into those negative numbers, right? Which are always less than positive numbers. The height of a first grade student is blank the height of a 6th grade student. Well, typically, the height of a first grade student is shorter than that of a 6th grade student, which means less than because shorter is fewer inches. And then the time, oops, do you see how I made a mistake? Less than the height of a 6th grade student. The 6th grade student's height is going to be greater, and so the crocodile is eating the height of the 6th grade student. So it's very easy to make mistakes, as you just saw, and so let's make sure I'm not thinking ahead and we're taking our time on each one. The time to eat lunch is blank the time to brush your teeth. Well, I know some of you probably eat lunch much faster than you brush your teeth when you're trying to get out to the playground to play at school, but typically the time to eat lunch is greater than the time to brush your teeth. Okay, So in this first lesson, you're just really starting to get comfortable with your new symbols. You've been working with less than and greater than for some time now, but we also have the newest symbols, less than or equal to and greater than or equal to. Okay, so again, this is just combining the equal symbol with the less than or greater than symbol because, as we saw above, there are situations where the solution to a variable or an unknown could be equal to a number or it could be greater than that number. Okay, so I'm going to give you a chance to think of a few more keywords, and you actually have these, I believe, glued into the back of your comp book in that clue words page I gave you. But we know this first symbol as being less than. It also could be fewer than, or think of some other ways, below, some other words, below, under, right? Those are some other words that mean less than. Greater than, more than, above, over, right? And you can probably think of more words, and make sure you're adding those words to your comp book as you think of them. Now your newest ones, less than or equal to and greater than or equal to. So less than or equal to could be written as at most, or as we saw above, maximum, or no more than. Those are some. Can you think of others? And then we have greater than or equal to and at least. Okay, well, we saw above minimum. No less than. And again, you could probably think of more, and you're going to want to add those and as you see examples. But when you see these key words, then you know to use that specific symbol. Just like I taught you how to use the equal sign when you saw the word is, or was, or has, or will be, right? Any form of is. Now you're looking for maximum, no more than, above, over, to indicate the solutions could be more than one of them, not just equal to one number. Okay? Inequalities can be solved by finding values of the variables that make the inequality true. And you'll learn how to solve inequalities later in the chapter. So for today, all you're doing is you're trying to find out which numbers would make this solution true. So this first example, it says, of the numbers 8, 9, and 10, which is a solution of the inequality? So it's asking you for one solution here. Okay, not to say that it's the only solution, but of the three numbers provided, 8, 9, and 10, you are trying to pick the one out of those three. Well, the easiest way would be to substitute in. All right, so I'm going to do 8 minus 3 greater than 6, 9 minus 3 greater than 6, and 10 minus 3 greater than, oops, not or equal to, greater than 6. And I'm going to solve each one. 8 minus 3 is 5. Is 5 greater than 6? The answer is no, because we all both know that 6 is to the right of 5 on the number line, which means it's greater. We also know, I mean, having $6 is much greater than having $5. Well, not much, but 4/4 greater. So we know that's not a true sentence. So then if we go ahead and do this next one, we have 6 greater than 6. This is also not true. 6 is equal to 6, not greater than 6. So you cannot use that greater than symbol. Now, could we have used our new symbol? Absolutely. We could have used 6 is greater than or equal to 6, but that's not what this question is asking. And the last one is 10 minus 3 is 7 greater than 6. Yes. 7 is farther to the right on the number line, therefore it's greater than 6. Now, instead of substituting all of these and finding them out, because you know I like you to show your work, not just do mental math, is you could have actually done what? Let me write the inequality over here. To find out which of those values was the solution for n, I could have isolated n by using inverse operations to see which number was greater than 6. So if I add 3 to both sides to isolate n greater than 9. Okay? I just told you or solved and proved to you which of the 3, 8, 9, or 10 was the solution for this inequality, because by isolating my n, I was able to determine that n must be greater than 9. Okay, well that means it couldn't be 8. And if it has to be greater than 9, it can't be 9. So the only number that fits of those 3 that was given was 10. So this is the way I would do it. Instead of doing 3 problems, I was able to do 1 problem and identify the correct one. So in your assignment, you can do it by isolating the variable, solving for the variable, or you can substitute them, all 3 of those options into the inequality and solve. Okay. In this next one, we're going to use the inequality symbol greater than or equal to. So it says 17 is greater than or equal to 11 plus x, where x is equal to 8. So it's telling me that x is equal to 8. We need to find out if that is actually true. Well, again, I could, if I wanted, isolate x by using inverse operations. I'm going to subtract 11 on both sides, and I'm going to have 6. Okay, well, look at what this is saying. Remember, the inequality is facing the bigger number. So eating the bigger number, and so it's eating 6. That means that x has to be less than or equal to 6. I just flipped it around because I like to see it the other direction. You can read it either way. Then I go back to my solution they gave me, x equal to 8. Well, let me substitute that in for x. If I substitute in 8, is 8 less than or equal to 6? No. Therefore, 8 is not a solution. And the other way to do that is to actually substitute it in. So over here on the left, if I substitute in 8 for x, and I add 11 plus 8, and I get 19, this is saying 17 is greater than or equal to 19. That's not true. So since 17 is not greater than or equal to 19, 8 is not a solution of this inequality. But I would be able to tell you what a solution would be because I solved it over here on the right. I know that any number less than or equal to 6 would be a solution. Now, I'm not going to list all of those numbers out because that is an infinite amount of numbers. It could be 5, 4, 3, 2, 1, 0, negative 1 million. It could be 125 thousandths. It could be negative 500 thousandths. Do you see where I'm going with this? And because of that, we do the inequality statements so that we could list all of the possible solutions without missing any numbers and not take forever to do so. Because honestly, we would never be able to write all the solutions for this inequality. if we had to write every single one of them. So we just have this nice blanket umbrella inequality statement and sentence that says any number less than or equal to 6 will be a solution of this inequality and will make this inequality true. Okay? So this is what you're doing. This is an introduction to inequalities. Miss Sipa will have one for you on writing inequalities. So that's where you're going to really get into and practice using these new inequality sentences with the greater than or equal to or less than or equal to symbols.